Okay, now let us take stability of submerged bodies. Stability of submerged bodies. I think I've started recording, students, correct? Please tell me.
Yes, sir.
Yes? Okay. So now if I consider, no, I'm sorry, not submerged body, I'm very sorry, submerged body is all done. Floating bodies. Submerged body is done, right? We have seen how buoyant for center of buoyancy and center of gravity. Okay, the interplay between center of buoyancy and center of gravity, where it is located, determines the stability of the submerged bodies. Always when it is bottom heavy, the submerged body is stable. Correct? When it is top heavy, it is unstable. Simple. Okay. So when it is bottom heavy, the gravity, the center of gravity is coming below. That is the big thing. Okay. So now let us say a floating body. So floating body generally when you say it's a ship that is taken into consideration. Right? So let me have a ship. No, let me have it like this in a simple way, not this. Okay. Because for me drawing is complicated. Okay. So let me have it this way. Okay. This is my ship I say. Okay. This ship, for example, what I'm going to do is, okay, what I'm going to do is, I'm going to tilt it. So now if I see this, you say is the main axis, and this is the level till which water is there. Okay, this is the ship deck. Okay, this you can say deck. Okay, DECK. It is called deck. Okay. So now see in ship there are three types of movements. One is called pitching. See, this is the ship, for example. I will write using mobile. Okay. Say this is a ship. Okay. This is the length of the ship. This is the width of the ship. Okay. I hope you're able to see my mobile here. The width of the ship. Okay. Now, if it goes like this, it is called pitching. Do you get this one? This is pitching. Okay. This is yaw. It goes here and there. You see this? This is the case. It's going here and there. It's called yaw. Pitch, yaw, and roll. You see, it is rolling. Okay, pitch, yaw, and roll. Okay, so these are the three type of things which can happen. One is pitch, yaw, and roll. It is considered that the most unstable way is rolling. Okay, so if this is a cross section of the ship, cross section in the sense, if the ship is something like this, it is the deck of the ship. That's okay. I'm putting a boat here. Cross section is here. It is cross section. This section. This is what is the section I'm taking. Okay, so that section I'm putting here. Okay, so what is happening? It is rolling that is happening. Okay, so now if I roll it by a bit, by some means, okay, by maybe because of the waves, or maybe because some people have come from the center to the side. Okay, so it rolls. So this is the level of water, I'll say, and then say it has rolled by a bit. Okay, so it has rolled. Hmm? By a small amount, it has rolled. And this is the new axis. Now, if I consider here, in this case, I'd say this is A, B, or let this be ABC. Okay, A, B, C, and D. And this let it be the free surface of water. Okay, EF. Okay, EF. EF represents the free surface of water. Now, if you see where is the center of buoyancy? Center of buoyancy generally will be the center of this part, is it not? The center of E, F, C, D. The center of that would be center of buoyancy, correct? Okay. The centroid of the submerged surface, the submerged part, submerged part. E, F, C, G is the center of buoyancy, correct? Not sure my buoyancy word is proper or not. Am I correct? Okay, let it be. Let us see. Okay, no, my spelling is wrong, students. Okay, it is buoyancy. B-U-O. Okay, it's not B-O-Y. B-O-U-Y. Okay, I do a mistake sometimes. Yesterday I noticed that. Okay, so buoyancy. Okay, so now what happens because of this buoyancy? There is a force which is directed upwards, is it not, students? So this buoyant force is upwards, has to be understood. Okay, next, center of gravity. It depends. It varies. Correct. It may be below the center of buoyancy. When that happens, when heavy things are put at the bottom. Generally, what they do is they put heavy things at the bottom. So if you put heavy things at the bottom, the center of gravity will be lesser. Okay, because on a ship, especially the cargo ships, there are a number of materials which comes. Okay, we were. I was involved somehow in Bandar. Okay, in Bandar, there are a lot of boats which goes to Lakshadweep. Okay, so there those things matters. It depends on which goods has to be told put in which place matters for the stability of that particular boat or a small ship. What is taken, it's not a big ship, which is a it's small only. It can take around say around 50 or 50 to 100 tons it can carry. Okay, the bigger ships can take lakhs of tons. Okay, yeah. So here this is B. Okay, the center of gravity variable is G. Okay, now at this G it is coming down. Now when it is rolled, okay, center of gravity position does not change, is it not? It remains the same, correct? It may then what happens now? If I say EFGH, okay, EFGH may be somewhere here, okay. So let me put EFGH. Okay, so this is my A, B, C, D. This is E, and this is F. Okay, so G was a bit below here, right? G, correct? Now what happens? The center of buoyancy here. Initially it was here, right? This was the initial center of buoyancy. Maybe shifted somewhere here. Correct? Now, or it may be shifted somewhere here. It can be anywhere from this point to this point. Depending on the center of buoyancy and center of gravity, you can understand the how the stability is. How what happens now in case I have this center of gravity is acting here, right? Center of buoyancy is acting up. Okay, that has to be understood. Now here, when I tilt, if the center of buoyancy goes beyond this line, observe there is a line here. Okay, this line, if it is going here, then what happens? If the center of buoyancy shifts to the left side of the line, there is a restoring force. You see that? It restores it. There is a restoring couple. In case it comes somewhere here, then there is a, toppling couple, is it not? So if in case this shifts, I'll write it a bit bigger. Okay. So let the buoyancy be like this. Okay. It goes here. Okay. So I'll say this is B. I will say over here B1, here B2. Okay. Somewhere here I'll say B2. Now understand. Okay. Figure you can write later on, but understand first. Okay, I'll give you time to write until you say not finished. I will not do it. Okay, so now if the buoyancy, if the center of buoyancy, if the center of buoyancy shifts to B1, if the center of buoyancy shifts to B1, okay, what happens? The boat or the floating body experiences a toppling moment or what do you say? Yeah, toppling moment. I can say toppling moment. Okay, which further makes it unstable. Correct. Which makes the floating body unstable. which makes the floating body unstable. Okay. Now, other than that, this is first one. Second one, if the center of buoyancy B, okay, center of buoyancy, if the center of buoyancy B shifts to say B2, there is a restoring couple. There is a restoring couple that makes the uh, floating body stable. Correct. So that is the main thing here. Okay, where does the center of buoyancy shift? Okay. Now, how to say that? We use something else called Metacentre. Okay, what we do is the previous CB line, we draw a line to previous center of gravity and center of buoyancy, and this B, what is there? We will join a straight line. Okay, like this. Okay, wherever it meets, that particular point is called the Metacentre N. This is called the Metacentre. Wherever this meets, it is called the Metacentre. Now here, this can be interpreted like this. Whenever Metacentre is above the center of gravity, whenever the Metacentre is above the center of gravity, the floating body is stable. Whenever the Metacentre is below the center of gravity, the floating body is unstable. Simple and straight. Easy. So it depends on the relative position of Metacentre and center of gravity. Hope it makes sense, students. Correct?
Yes, sir.
Yes, please write it down and then we will go much further. Write it neatly, students, and understand. Okay? Because things can be told easily and move forward, but the in-depth understanding is required. So it's okay. These are basic concepts, and if you remember that, it's better. Done, students?
Yes,
Okay,
sir.
no urgency, but done. You have to tell me, otherwise I'll not move forward. Okay, because I'm going in your pace, students. Okay. So now, especially with respect to concepts. Okay. Now, Metacentre is not a. This is one of the questions that may be asked. It doesn't depend. It is not a constant position. It depends on the angle of roll, theta. Okay. So very important to know that Metacentre depends on the angle of roll. Right. Metacentre depends on the angle of roll. So you still roll it still more. It's very important thing to note. Okay. So you roll it much more. Then what happens? The metacenter shifts. When it is vertical, metacenter is just above the center of gravity. Right. So you shift it a bit here, you make an angle, it will be here. You make still more angle, it will go shift again and again. Okay. So it's important to know that metacenter depends on the angle of roll. Okay. It is not a constant. Okay. Very important. Okay. So now let us understand once this is done. Now here, let us put it a bit better. Okay. Now in case of stability of the boats, okay, if I say this is the boat here, okay, say the maximum for a particular roll angle, okay, for a particular roll angle, very important to mention that, and it's not mentioned a lot of times, okay, in textbooks, okay, and that creates a bit of confusion, okay, for the person who is thinking, okay, a thinking person, it creates a confusion, okay, because nowhere it is told, it is seen that Metacentre is a constant, this one, it is not, okay. So what happens here is, if I have this like this, okay. So you say for a particular theta, for a particular angle of roll, okay. This is B, this is G, and this is M. For a particular roll, okay. We have not rolled it, but still we are saying that is the maximum level till which M can go. Minimum level will be always G, okay. So now, what is important for stability is the height Gm, okay. So Gm, the distance Gm distance gm, which is called metacentric height. Metacentric height determines the stability of a floating body. Determines the stability of a floating body. Now this gm is actually equal to bm minus bg. Very important. Okay. So now if gm is greater than 0, then it is called stable equilibrium. It is called stable equilibrium. Okay. And this Gm is equal to 0. It is called neutral equilibrium. It is called neutral equilibrium. If Gm is less than 0, then it is called unstable equilibrium. Then it is called unstable equilibrium. I hope you get that, students. Okay, write this down. Next, what is the importance of metacentric height? I will tell you. Okay, it's not just in stability. Okay, there are some more things involved with it. Okay, so let us see one by one. See, there are two ways, students. One is diploma approach, one is degree approach in the sense once you complete your graduation, graduate approach. These are two different things. Diploma approach is let us do it. Okay, we don't know anything, let us do it. Okay. Graduate approach is okay, we will do it, but let us do the calculation first so that we will reduce the amount of repetitions that we have to do. Correct. So when you see in the graduate level, when you go, then what happens? The cost of making a new prototype will reduce like anything. Okay. In India, most of the companies, um, because our we don't have good mathematical background. Okay, even though we say we are good at mathematics, we are actually not good in mathematics. Okay, especially engineers, we are not. Okay, we don't learn. Okay, our attitude is, it's very sad to say, but our attitude is towards marks, towards seeing what you say, getting salary, getting promotions. That is our attitude. Okay, so that does not create excellence. Okay, now you go with a learning approach. You want to learn because these are all very interesting things, students. Okay, let me learn, let me try. Okay, I'll tell you, you will not be dependent on any person. Okay, and engineering degree, your marks become so unimportant because you're so good. Nobody can ignore you. Correct? So that is the level which is very, how to say, very nice. Okay, you do a job, fine, don't worry, but you do a job to learn. Okay, if you have sufficient, in a sense, happiness in the job, continue that. Okay, so it's important. Okay, but you have to be on your legs. That tomorrow, if the job scenario goes down, you should have a backup. Okay. Huh. Now, experimental determination, experimental determination of of metacentric height. Metacentric. Okay. How to determine experimentally what is the metacentric height? Okay. What you do is we have, this is important, is asked in interviews. Okay. Okay. Let me draw a straight line. You understand that. Okay. Because for me, drawing straight line is easy, students. Correct. So let us take a ship in a straight fashion. Okay. Although it might be something like this. Okay. It might be something like this, but we will take it in a straight fashion. Okay. So here I will say initially make the ship by moving the goods here and there. Okay, that's what is done generally. Move the goods, a container, it's a container ship, for example. Okay, make the container so that it will attain stability. Okay, that can be done. How it can be done? It can be done by using something called, the name of that is called, you have that vertical line, is it not? I don't know what is it called. Okay, um, what your a weight tied with the this one, a weight tied with a string. Okay, civil engineers can answer me. What is that? Any civil engineer here? Okay, just a weight. It's held with a hand. Okay, the Maestri uses it generally. Okay, it is called line. Some line it is called. Okay, it's not there here. Okay, it is just a string tied with a weight. That's it. Okay, so always it follows gravity. So this will be the vertical line, is it not? This will be vertical direction. Correct. So now you hold a string here. Okay, if the string is vertical like this, okay, when you're standing here, okay, it shows what is the vertical direction. Okay, if it is tilted, it will tilt. Okay, the vertical direction will tilt. So like that, what you can do is you can actually, no. So if you put something here on the board, okay, you put a board. That's how it is done. Okay, there is a board kept on the deck of the ship. Okay, there is a board kept on the deck of the ship, which shows the vertical axis, the centroidal axis of the ship. Okay, it is drawn. Okay, now what happens? Then you use this, what do you say? Uh, so okay, fine, it's okay. Okay, you use that string with this one. Okay, if the ship is tilted, what will happen? This will go like this, is it not? It's go like this. Okay, and this will be here. Okay, this is the string tied with the stone will be like this. So you know it is tilted. Okay, because when it's a big ship, you don't know how much is the tilt. You have to measure it properly. Okay, so this way it will happen. So now what happens? Initially, make it vertical straight. Okay, now what happens next? What you do is you take the same ship and tilt it. How do you tilt the ship? By moving the goods. Correct. You move the goods. You have tilted the ship. Correct. You move the goods somewhere here. Okay, initially let the goods be here like this, then you move it. Okay, this is the vertical line, correct? And here it is P. Say this is a small load P. Okay, and because of that there's a tilt of theta. Okay, this can be seen with that line. Okay, with this line we can say what is the theta, correct? Theta can be measured, correct? So now what is going to happen is, initially, say G was here and B was here. Okay, G was here, B was here. Okay, so it is like this and this one. Okay, now when you tilt, what is going to happen? G is going to shift to G dash. Okay, B is going to shift to B dash. Okay, and this G, the previous G, because the reason why this has tilted is not external causes, it's because of that P. Okay, so G has to change, is it not, students? And the previous one would be G and B. Okay, I'm writing it a bit differently. Okay, wait. The previous one has to be, the previous position has to be, say over here, G and B. Say this was the previous position. It has moved to new position. And say I can measure by what distance I'm moving this X. Okay. So now what is going to happen is my P into X, my P into X is actually equal to weight W of the whole ship, how much it has moved, into G into G dash. Agree? You get the point? How much the center of gravity has moved is proportional to this moment, is it not? Agree, students? P weight we know, whether it is 10 ton container or 5 ton, it is generally 25 ton containers. Okay, containers comes in a big one. Okay, so you move a container. You,
Sir,
yeah, tell me.
sir, why has G changed?
Because
Sir, previously we didn't change it, right?
yeah, previously when I say here, what has happened? It is because of the external causes that the change is happening. Okay, but here what is happening? Here I am moving the container, so the G of the whole thing has to change, is it not? Because I'm moving this one portion over here. Correct? G has to change, is it not?
Yes, sir.
Got the point? Should I further explain? Should I should I use this one? Okay, I'll do that. Okay. So what is happening sometimes? How do you calculate G? Okay, you calculate G by, say there are slots here. Okay, say there are some slots. Okay, wire meshes or a shelf or something like that. Okay, on a ship there is a shelf. Okay, so now if I put heavy object here, heavy objects here. Okay, what will happen? G will be down. Correct? If I move this heavy object to the top, the G will move up. Is it not? Now, if I take the heavy objects which are there, I will put it only here. Then what happens? G will move somewhere here. Correct. So moving the objects, I can change G. Correct. It's center of gravity where the whole weight may act. Is it not? I hope you get the points. Okay, fine. Okay, please, if you don't get the point, please tell me. I can go to the depth and explain you everything. Okay, don't keep any point where you have opaqueness. Okay, let it go with the basics from the first principles. Let it go. Let it go. So P into X is equal to W. W is the weight of the ship. Okay, G dash. Correct. Now G into G dash can be written as G into M. G into G dash can be written as G into M tan theta. Correct. Agreed, students? Because G dash is this. This is M. tan theta, correct? GM tan theta, correct, students? This is theta. Agreed? Okay. So now I can write GM is equal to, we know what is GG dash. What is GG dash? P into X divided by W. So I can write P into X divided by W. Okay, that is GG dash. Okay, so GM is equal to GG dash divided by tan theta, which is cot theta. Agreed? So what happens? GM depends on what? GM depends on, come on students, theta, correct? GM also depends on theta, right? So these can be changed, it depends. Okay, P into X changes theta after all. So metacentric height is a function of theta. Okay, this is the question in some of the interviews have been asked. Okay, yeah, it's a common question. If you go to some of the oil petroleum companies like ONGC or say BPCL, they have barges, offshore barges, and the stability of these barges is very important for them. Okay, so in that case, if you say fluid mechanics is your interesting topic, they will ask you something related to stability for sure. Okay, and if you go to HAL, okay, they will ask you about compressibility. Okay, they will ask you more of thermodynamics. Okay, and if you say fluid mechanics, then they will ask you something called drag and lift. Okay, because that is more important for them. Okay, and yeah, buoyancy also they will ask. Okay, but more important for them is drag and lift and Navier-Stokes equation. Navier-Stokes equation, wherever you go, Bernoulli's equation, Navier-Stokes equation, starting from first Newton's law, they will ask. Okay, and take it away from your mind that there you have very complex things to be asked. No, nobody asks complex things. Okay, nobody expects you to know FEM and CFD. Okay? Although some terminologies, if you know, it will be much more better. But everybody knows that a basic engineer, that BE person, cannot know more about CFD and FEM. That is granted. You cannot know it. Let me tell you, it's very difficult. Only some geniuses will know to the depth of. Okay, who should have been initiated from initial. They should have started studying from around the first year. They should have been initiated for that. Okay, then they can do it, and they should have a good teacher. Then they can do it. But otherwise, no, it's not possible. So what is possible? Learnability. And learnability is measured by how much you've learned till now. What is your approach of your learning? Correct? It doesn't depend on how well you solve problems. Okay, because in engineering scenario, in the realistic scenario, which most of you are going to go, okay, it is imagination that is important. Whether you can figure it out. Okay, even calculations is required. But before calculation, that understanding, okay, fine, this is moving here, so how the metacentric height changes. Understanding simple things, correct? That matters a lot. Okay, and most of the things can be done by common sense until and unless it is fluid dynamics. It is counterintuitive a lot of times. You think this should happen, the other thing will happen. So there you require to do calculations. Yeah, students, tell
Sir,
me when
could
you
you
finish it
explain
off.
P into X is equal to WG?
Complete. Huh? Yeah. So now, why this P into X becomes W into GG dash? This is the question, is it not? Let me explain. For example, let us take this. Okay. Let us take I section. Okay. Let us take I section. Okay. And say, okay, let there be I section. Okay. Now for this I section, say center of gravity is over here. How do you measure the center of gravity? You take similar things and you say this is A1, correct? This is A2, this is A3, correct? So with respect to a particular axis, say X and Y, both, right? So you say center of gravity, say Y bar, if I say this is say X, this is Y. Okay. So Y bar is equal to A1 into M1 plus, sorry, it is Y into M1 plus, or area you can say. Okay, M1 also you can take area also. Just take area. Okay, Y1 into A1, Y2 into A2, Y3 into A3, like that, is it not? Let me put it in the next slide, okay, so that I put it. You have this I section. Oh, sorry, just a second. So here, one of the things is that I'm not worried about completion. Okay, in the sense, understanding is more important than just completion. Okay? That is the motto with which we go. Okay, so yeah. So now I'll say here, this one here. This is 1, 2, 3. Right? So we'll take this as x, and this is y. Okay. So y bar is equal to. Now I'll take another one here. One more. I will take 4. Okay. Just like that 4 I've taken. Okay. Which has some other okay, let it be 4. Okay. So what is happening? Y is equal to y bar is equal to, say, a1 into y1 plus a2 y2 plus a3 y3 plus a4 y4, correct, divided by sigma a, correct. Now y x bar, what is x bar? X bar is equal to sigma of a y divided by a by I, a I b I divided by sigma of a I, correct. This is how we do it, is it not? So now in case I move this on this direction, I move this by x. I move this by x. Now, oh sorry, this x bar is x. Okay, I'm sorry. I move this by a small portion x. What does it imply? When I move this by a small distance x, this x1, which was initially a1 x1, a2 x2 plus a3 x3 plus a4 x4 was there. Okay, so this will be x4 plus x. I'll say x, what I can say, dx, I will say, plus dx, right? x4 plus dx divided by same sigma ai. Now, don't you see that the initial x bar changes? Is it not? What was g here initially? You see, because this additional one which is moving here, don't you see that it moves on the other direction? By what amount? By what amount? The amount is a1 into dx. Correct? It moves by an amount a1 into dx. It moves by a1 into dx divided by sigma a. Correct? That is equal to x bar. Correct? Or I can say a1 dx is equal to x bar into sigma a. Now instead of area, put the mass there. So if I put the mass there, so let's say this is a1 instead of a1. Let us put it p. Instead of dx, let us take x. Instead of x bar, let us take this one. What do you say? Instead of a1, we have taken this one, right? So x bar is the new x bar, right? This is the x. Okay, this x bar is a new x bar, which is gm, is it not? That's the new x bar, g dash. Okay, the new x bar. I can say dx here. Instead of this, we will take g dash, the moment which has happened, correct, into the beach, correct. Agreed, students? Correct. So p into x causes, okay, so here x bar involves all the things. I'm sorry, x bar involves everything. Okay, x bar involves all these things, correct. So now what happens? A1 into dx is the difference between, you can say, a1 x1 plus a2 x2 and so on into plus a4 into x4 plus dx divided by sigma ai, correct, plus we have the what do you say, sorry, minus the initial one, correct, minus the initial one. Now what is happening here? That determines what is dx by amount, what it is shifted. So what it is shifted is proportional to this, is it not? Correct. This x and this y is proportional. And what is the proportionality limit? W by p. Correct. Agreed. Agreed, students. Are
Yes,
you
sir.
convinced with me? Are you convinced with me? Fine. If you did not get this further, I'll come again. I can go to much deeper. Okay. So that is how you do it. Okay. Next. That's nice, students, that we are going with a very nice way. Okay. Fine. Next. Now, one of the important things about metacentric height is that, okay, we will see it later. Okay. Now let us see analytical way, analytical method to find the metacentric height. Analytical way to find out the metacentric height. Analytical method to find the metacentric height. Let us do that. So now let us have, say, a boat. Write this neatly, students, very important, because we are going to have a lot of things at this. Let us have a boat like this. On the cross section, you know which I've taken. Okay. It's a cross section of the boat. You see this like this. Okay. In this way, that's a cross section. Okay. So let us say that the water level is here. This is the water level. Okay. So I think you are imagining a boat. Imagine the boat. Don't say it is just like that. Imagine the boat in your mind. Okay. So let us take a point G over here. Okay. And then let us take a point B over here. Okay. Generally, center of if now the question arises, sir, if G is below B, then what will happen? Correct. Sir, you are taking always G above B. If G is below B, then what will happen? Think about it, students. Okay, I'm not doing that. Okay, you have to tell me. You have to message me to say if center of gravity is below the center of buoyancy, then what will happen? Okay, that is for you to think. Okay, now in this water which is there, I'm tilting this. Okay, let me tilt this. Tilt so much that it will not. Um, God's huge. Wait a minute, friends. Let's say it is tilted. Okay, by a small angle, it is tilted. Okay. Now, once it is tilted, what you can find is this is the initial one. Okay, this is the initial one. The initial was G, then it was B, correct? Now, what's going to happen is metacentric height is going to be somewhere here, correct? Where the B changes. The B changes, and this would be the metacentric height M. Okay, GM would be the metacentric height. Okay, so let us take this point as O, which is the point around which it is tilted. Okay, so now if I take that, say it is tilted by an amount, say something goes above, something goes below, right? And you say both are equal, although my drawing is not that great. Okay, both are equal. Okay, now if I take, okay, so this is, say, this is A, figure A, this is figure B, and then say figure C shows how it is when you see it from the top. This is the top view of the boat. Okay, this is the top view of the boat, and let us take this axis as Y. Okay, and this as X. Okay, X and Y. Z, if X and Y is there, Z has to go up, is it not? Wait a minute, students. That is Y, this is X. Z has to be up. Okay, let it be. Okay, if Y has to be done other way around, okay, let us put it like this. Okay, let the Y be in this direction. Okay, positive Y be in this direction, so that Z is in this direction. So this is the direction of positive z. Okay, fine. We take positive z or negative z. So if I put y on this direction, x on that direction, y will be in the below direction. I hope you are able to imagine the three-dimensional boat here. Correct. Very important to imagine, students. Anybody can do calculation, can by heart and do the calculation. But we engineers have to imagine. We have to be there. Have you gone to the seashore or riverside in your mind? Okay. The Mangalore and areas have a lot of rivers, is it not? India itself has a lot of rivers. Okay. Wherever you go, 100 kilometers, you get a river, small or big. Yeah. In this part of India, we have every 20 kilometers we have a river. Correct. So, so imagining boat is not so difficult for us, is it? And we have a sea beside, is it not? Yeah. Alexander felt it very difficult to come to India because every few kilometers there was rivers, and that too very big rivers. Okay, whether it was Indus, so many tributaries are there. What you see on the on your map is very small portions of the river. Small rivers are not seen. Number of small rivers, and that was a source of frustration for him. What we have today as Alexander's this one are their accounts, is it not? It's Europeans' account. We did not preserve our account. Our accounts are there, not that it's not there. We have written it down. Okay. We are much more civilized than what Europeans think. When they were barbarians, we were at the height of civilization. It's because of the loot that we are like this. China was also like us only. China is not no different from us. Okay, culturally, China, Japan, the whole of Southeast Asia, these are all culturally very, very sane, I can say, civilized. Today, China is uncivilized. They are trying to become US. That's the problem. If they remain China, then there's no problem for the world. With the imported ideology, which is not Chinese. Correct? Communism is not Chinese. By the name of cultural revolution, they have destroyed all the Shaolin temples, where actually Kung Fu started. Yeah, anyhow. Yeah, students, they finally finished writing this. Can I move forward?
Yes, sir.
Yes, very good. Okay, you have to tell me, otherwise I'll just wait. Okay. So now what is happening is, see here. Now if I say this is Z, okay, this is Z direction, correct? So now if I say the volume by which, okay, it is immersed here. What is the immersion? If you see the volume of, say, x dash into x dash of b, volume x dash b. What is the volume x dash b? When we have shifted here, say this is theta, say this is theta angle, it has shifted. Okay, this is moved by angle theta. And now if I see, if I take at a particular z, let us take a small area here, small elemental area here, volume actually, and this volume goes here like this. Okay, this is our elemental volume. Okay, so my elemental volume goes here. Okay, so this is the elemental volume. Okay, so this is elemental volume. Okay, and the depth here, the distance here, okay, this distance, okay, how much it has gone below is very important. Okay, so now if I say this one, this distance, this elemental volume is not going till there. I'm sorry, it is going till here. Sorry, it is going till here. Okay, this is the elemental volume area. It goes till over here. Okay. Now, if I say this is Z, initially it was Z, and then there is an additional one. Okay. So you say this is Z, and then there is an additional one which goes below because of tilting, which is dz. Okay, initially when it was there, it would have been at this position, correct? This z would have been here, correct? Now this, when it is tilted, it would have been shifted. Okay, so additional dz is there. Okay, now this volume would be equal to, if I say the volume of this elemental volume. Okay, now here initially, if I say initially for this elemental volume, okay, for this elemental volume, let us say, or volume, let us take, okay, volume of which is immersed xb. Okay, so if I take the coordinates, okay, in such a way, yeah. So now, if I consider where is the volume of x which is submerged, okay, volume of x which is submerged, okay, submerged volume, let me put it like this, volume submerged initially, okay, volume submerged, if I say, or I'll put it volume s, okay, submerged. I hope you'll understand volume submerged. Volume submerged, if I say, it is equal to integration of z dA into x. Agree? So initially, if I say initially, volume submerged is equal to integration of z into dA, all dAs, correct, into x, correct? That would be the volume which is submerged. Okay. Now, no, volume would be submerged would be this. Okay. Initially, if I consider, okay, so if I say the x coordinate of the center of buoyancy, okay, so that would, that's not volume submerged is, initially volume submerged is vb is equal to v submerged, let's say v submerged is equal to integration of xdA, zda, correct? Z is below the, this is 0, it's below that. Okay, so now if I consider center of buoyancy of the submerged volume of the floating body, if I consider center of buoyancy of the floating bodies, if I say xb, if I say floating body, center of buoyancy is the center of that, is it not? That is integration of z into dA into each x, is it not? X is the distance to the, say this is x, correct students? So if I consider the center of buoyancy initially, when you say it is xb is equal to integration of zax, correct? Correct students? Any doubts here? Till now, is it clear? Or is it wrong? Okay, let me put it. Okay, so it is xb is z into dA is the volume into x, okay, divided by volume into volume. Okay, now it's proper, correct? So volume submerged into xb, volume submerged into xb is equal to z into dA into x, correct? Agree students? So that way we can find, let it be, I'll use the equations which is given there. Okay, so let this be 2.59, okay, 59, equation 59, which is given in SOM also, the same equation I'm using. Okay, equation 59, let me use that. Okay, any doubts till here students? Can I move forward? All the doubts are clear till here? No, I'm not
Sir,
hearing.
here you are referring to which diagram?
Huh?
Sir,
Come
you are
again.
referring to which diagram?
I am referring to this diagram, Baba. Okay, I'm referring to this diagram. Okay, initially, I've told initially, I'm referring to this diagram. I can find out the center of buoyancy, how much it goes beyond x, because center of buoyancy will have x coordinates and y coordinates, is it not? If it is symmetrical, the boat is symmetrical, then center of buoyancy will be at the center. Otherwise, it will move here and there. It depends on what? Z into dA into x. Correct? I hope I'm clear.
Yes, sir.
Correct? Okay. Next, let us go. Now, because of the tilt, okay, once the body, floating body is tilted, once the floating body is tilted, once the floating body is tilted, the center of buoyancy, center of buoyancy shifts from, say, xb to xb dash. We'll assume that. Then, then V, that is the volume submerged, okay, into x dash b is actually equal to integration of, instead of just z, it would be z plus x tan theta into dA into x. Agreed, students? How that x tan theta comes? Because you see this dz, if you see here, if you observe this dz is actually equal to x, which is this distance, correct? This x into tan theta, correct? So when you're integrating z plus x tan theta, correct? Here it might be negative, here it might be positive, correct? So it depends on the theta, right? X here, when x goes negative, this goes negative, that much we have to negate, correct? That much less it will happen, correct? So that's how it is. Is that clear, students? Till here it's clear. Fine. Fine, students. Yeah, please write it down. Now let us take this as equation number 60. 59 is over 60. Okay. Next one. Subtracting. Subtracting. Okay. 59 equation 59 from 60. Okay. Subtracting 59 from 60. We get volume submerged into xb dash minus xb is actually equal to integration of x square tan theta into dA. Agreed? And this can be written as tan theta into integration of x square dA. So that would be volume submerged into xb dash minus xb. Is it clear, students, here? Now, what is x square dA, students? What is x square dA? X square dA is moment of area, right? Moment of inertia I, correct? It's second moment of area, correct? So we will be substituting that in short moment. You can just write this down. Once you write it down, let next I will go for the next point. Students, we can go slow here, don't worry. Okay, understand.
Sir, that expression x tan theta, I'm not able to get it out.
Okay. So now what happens? It's simple, man. Nothing great. Okay. Take this triangle. This one here. This one here. This one. Okay. That triangle we will have it like this. This is O. This is here this way. Correct. So now what is happening? This is this way. Okay. So take it as a triangle here. Okay. When the angle is small, very important. This is dz is equal to this is x. Correct. So what is it? What is this distance? This distance is x tan theta because opposite adjacent. Correct. Correct.
Yes, yes.
That's it. Nothing great. Shall we move forward?
Yes, sir.
Okay. So now, next point here. Okay. Now, if I consider this portion, what is x squared dA? We know x squared dA is I, right? Tan theta. I what? I y y. Correct. So what is this? Since I y y is equal to integration of x square dA. Correct. So this is known. What is that? Moment of inertia with respect to y-axis. So where is y-axis? Y-axis is this. The bed, very important to know the moment of inertia with respect to the bed axis, this one. Okay, this y axis. With respect to that, we have to take the moment of inertia. You hope you get the point. This is the y axis. With respect to y axis, you have to take the moment of inertia. Okay, so very important point to understand. So that is I. Fine. Okay, another side. If I say this one, if I consider this side, okay, what is x dash minus xb? Xb dash minus x dash b minus x dash. That can be written as bm tan theta. Correct? How that can be written? If you see here, because of that, there is a change, you see. Okay, so x of b dash minus b dash is equal to, this is theta, correct? This is the angle by which it is good. So it is bm tan theta will be this distance. Correct, students? Great. So now here, what is going to happen is x minus x dash is bm tan theta. So what we can have? We can have this as volume submerged into bm tan theta. Agreed. Agreed, students. So now what is important? We need the metacentric height, which is bm, right? So now if you see here in this fashion, if you see, tan theta gets cancelled, correct? So what is going to happen is here, okay, if you consider like this, what is going to happen? X dash b is bm tan theta. So we can write bm tan theta is equal to I y divide, or volume is there, volume submerged is there, volume submerged there is equal to, if I consider on this side, tan theta into I y. Correct, students? Okay. Now with this, you can see that if I consider bm tan theta, if you consider like this, now here what happens? Bm is equal to I y divided by V submerged. Easy? Correct, students? Or I can write, since Bm is equal to Gm plus Bg, correct? Gm plus Bg is equal to Iyy divided by V submerged, correct? So I can have Gm, which is the metacentric height, is equal to Iyy divided by V submerged, correct? Minus Bg. Easy, students. So this is how analytically we can find out what is the metacentric height. This is the analytical metacentric height. It is invariant of theta. See that. This metacentric height is invariant of theta because we are taking small angle of changes, small angle change. Okay, we are not taking a large angle change. If I take the large angle change, what will happen? There is a problem with taking this tan theta because you see, he had the trouble at that time. There is a problem, is it not? It's not all perpendicular properly. Okay, this also there is a trouble. Okay, so only for small angle, the metacentric height is a constant. Correct? This is the analytical metacentric height. Easy. How we get metacentric height analytically, and this is very very important. Easy, students. Any doubts here? So, but this is asked to derive. See, generally in our public sector units, they ask you to derive, okay, to see how much understanding you have. Even if you miss the derivation, sometimes I've seen people who have not done the whole derivation, but still they have got selected. Why they have got selected? Because they approach this. They don't see just knowledge, students. Keep in mind, you may be worried that the interviewers will check your knowledge and you need to know a lot of information. No, you have to change the method you think. That's it. Nobody knows. Even the interviewers may not know a lot of things. Okay, they're not checking your what do you say depth in terms of vastness of information that you have gathered. There is one person called Tyson. Okay, Tyson is a Nobel laureate. Okay, he had this one. He said if somebody comes to I don't know what Tyson he is. Okay, there is a full form. I don't forget. Remember the whole Tyson. He's not Mike Tyson. He's some other Tyson. Okay. So he was saying, suppose there is a if I'm interviewing a candidate. Okay, the first candidate I ask a question. Okay, I ask a question that there is a tower in front of this building. Okay, can you tell me what is the height of that tower? The first candidate knows for sure what is the height of that. Second candidate does not know. What he does, he asks a permission, goes out and checks by his eyes how much it could be. He checks the angle and all those things, and comes by an approximate, what is it, crude approximation. Okay, so he say the first one who had the information, I will ask him further questions. But the person who has crudely imagined or crudely got the answer, that person I will surely select because he knows how to get information. Having information is not enough. Getting information is important. Your ability to learn is important. It requires a lot of practice. It doesn't come so easy. Don't think, sir, I don't have to remember a lot of information, so I'm happy, I'll stay safe, and I have a good learnability. No, learnability comes by practice and can be observed. Any student or any person, if you see, if you talk to a person, you can easily guess whether he's a knowledgeable person or a fluke. Okay? There are people who talk big things everywhere, is it not? But when will you say a person is knowledgeable? And that knowledgeability is seen in the words he says. And that doesn't come just like that. He has to go through that process. Only then such kind of things happens. You talk to IIT professor, the way they talk is different from some of our professors here, is it not? In a private engineering college. Why that happens? It happens because they have gone through the grind. The professors here, just like me, okay, we have not gone through the grind what IIT professors have gone through. Correct? So obviously there is a difference in the level. Okay? Yeah. Clear, students? Any doubts here? Okay. Next, let us see last one, period of oscillation. Let us take it or not. We will take it because we have 10 minutes. Okay. Next one, we will see period of oscillation. That is the last topic in metacentric and also the last topic in fluid statics. And then we will go for practice questions tomorrow's class. And from today's, from Thursday, we will start with fluid kinematics. Okay. So the second chapter is going to end. Okay. So now If I consider, say, there's a floating body here. Because of the floating body being there, here say I'll take a small weight. I will take a small weight and okay, if I say the weight is displaced, okay, the whole weight, I'm sorry, the weight due to some reasons, which is over here, has moved over here. Okay, the weight has been moved. Okay, the whole weight of the, due to some reason, the weight is moved from one place to the other. Okay? So now, if I consider the torque because of that movement, okay, the torque that is caused because of the movement. Okay, so let us say that movement happens because like this. Okay, so it is moved by say theta. This is m, this is g somewhere. Okay, it is moved. The g is changed. Okay, let us take. The weight is the same. Let us take the weight same. Now g moves from here to here. G to G dash. It has moved G to G dash by an angle theta. Okay. So now, if I consider here, okay, if I consider for small angles, okay, this distance, the motion, what is happening, I can take this as Gm sine theta for small angles because we cannot know which is hypotenuse, whether to take tan theta or sine theta. Depends on which is bigger, is it not? If I consider almost the same, I can say tan theta or sine theta. It doesn't matter for small angles. Okay, so I'm taking Gm sine theta, opposite divided by hypotenuse. Okay, so this I'm taking Gm sine theta. Now the torque, because of the what do you say, displacement of the buoyancy force. Okay, the torque torque caused by the motion or the by the tilting of the floating body, the floating body, I can take it as equal to W into Gm sine theta. That is the torque what is caused, correct? The torque what is caused is this distance. This weight was initially here, it came here. So the torque what is caused T is W into Gm sine theta, agreed? Because weight into distance, the toppling torque which has caused, agreed students? Okay. Now, what is resisting this torque? The resisting torque is proportional to the moment of inertia, is it not? Now, the resisting torque, okay, is based on, if you say, just like we have in case of linear motion, force is equal to mass into acceleration, correct? Force is equal to mass into acceleration, right? Similar way, in case of turning motion or what you say, rotation, it is torque is equal to I into alpha. Keep in mind. So the resisting torque T is also equal to I into alpha. What is I? I is the moment of inertia, correct? So it is resisting, okay? So I is the moment of inertia, what it is resisting, okay? And then that is equal to, that is the resisting one, okay? Now, into d squared theta by dt square, correct? That is alpha, correct? Now, just like you do F minus ma is equal to 0, we do here T minus I alpha is equal to 0 for dynamic equilibrium, not static, dynamic equilibrium. For dynamic equilibrium, this is an inertial one that you will see in vibrations further. Okay. Also, we will do mechanics is not complete. We know that. Okay. So T is equal to T minus I alpha is equal to 0. Now, if I do this properly, what is this? This can be written as T minus, so what is the torque? Torque is given as W into Gm sine theta, W into Gm sine theta minus I into d square theta by dt square is equal to 0. Write this till here, students. Then we will go a bit deeper on this. Okay. There are a lot of questions asked on this also. Write till here and tell me when you're finished writing. Similar questions are asked in vibrations also. So we have Yas coming now. Correct. There was Tokte, now it is Yas. India has been pounded by calamity, students. It's a very difficult times. It's war times, in fact. We are at war. Hopefully, we will come out strong after this. One of the greatest strength we have now, is that we are united. Never in the olden days, although we have lost Pakistan and Bangladesh, which is our own culture, which is our own people. Okay, but this amount of political unity was not there. This was there during the times of, say, one is with the times of, we have to go to BC, right, to see the amount of political unification what we have now. Afterwards, whenever it was there, it was not full of India. Correct? It was only till North India. There was one thing. The only person who came till the south, the whole India who conquered, was Ashoka and our Chandragupta Maurya. After that, this kind of unity never came to India. Although we have lost Pakistan and Bangladesh, but still, it's in terms of geographical area, and we are bound to become world powers. Okay, provided we stay united. Okay, it's natural, irrespective of the party which comes to the power. Okay, it doesn't depend on the party and the power. Okay, it depends on we the people. Okay? Party changes. Don't worry about saying that so BJP is good, Congress is good, Communist is good. No, anybody, even if Communist today CPIM doesn't have anything, even if that comes, even if Kejriwal comes tomorrow, okay, we are bound to improve. Okay. Yes, that's corruption is reducing. In fact, okay, it is not what was there in 90s. This is how social change happens. The same thing if you consider 1880s, the Labour Party tickets was auctioned actually. The black market, if you consider your British Raj. Okay, so like that. Okay, finished, students. Please tell me. Tell me when you finish. Okay, write it neatly, but we will take 5 more minutes. Okay, just we'll complete this one. Okay. Yes, students. Then we'll take 5 more minutes. Okay,
Yes, sir, done.
done. So now next. Okay, so now if I write this equation properly, okay, I will take W and GM below I, and I will write this equation. I'm sorry, it has to be minus here. Okay, because it resists. Okay, I'm sorry, I made a mistake here. It should be minus over here. Okay, it has to be minus here. It has to be minus here. So this would be plus. Okay, It would be minus I d square theta by dt square. It would resist. Okay, so it is coming back. Okay, very important. So it is resisting it. Okay, it is like you can say. We will give you some more examples where minus comes. Okay, we'll go to mechanics at the time. I'll give you that. Okay, now I'm not remembering. Okay, so what happens now? I can write this as d square theta by dt square plus W into GM. W is the weight of the whole ship into the metacentric height divided by IM. What is IM? It is the mass moment of inertia into theta is equal to 0. Where theta is tan theta, when theta is almost 0, tan theta is equal to theta. Correct? This follows from here. Okay. So this is a very, very important equation. Okay. This compares with x double dot plus square x double dot plus we can say k by m, correct, into theta is equal to 0. X by m into k by m into x is equal to 0. K is stiffness, m is the mass. So this is proportional to this. Also can be written as x double dot plus omega square. We can write it as omega square into x is equal to 0, where omega is the period of oscillation, or we cannot period of oscillation, frequency of oscillation. It is frequency of oscillation. So now here also, if I consider, this can be written as d square theta by dt square plus omega square theta is equal to 0, where omega is equal to square root of w dot gm divided by im, which is the frequency of oscillation, which is the frequency of oscillation. Why this frequency of oscillations become important is very important to understand. Okay, so now when frequency of oscillation is very big, there is a problem which is caused, that you become uncomfortable. If the frequency of oscillation is less, then you're comfortable. If boat goes like this, I'm happy. If it goes this way, gone. Correct? So, but what happens? More the GM, more the stability. Okay, more the omega, less the comfort. Okay, so it is seen that. See, I'll write again what is required here. So what happens here? The frequency is equal to square root of W into Gm divided by Im, correct? So, large Gm, more stability. That will not topple, okay? Large Gm implies more stability, okay? Large omega means unease, or you can say less comfort. Okay, and large GM means large omega. Okay, large GM implies large omega. Correct. So omega is more means GM has to be more. So GM is designed, the ship is designed in such a way, ship is designed for warships, I can say. Warships, these questions can come. Warships are designed in such a way, designed in such a way that GM is large to improve stability. But the luxury is compromised. Luxury is compromised as the omega is large. Similar way in your, it is like omega is the largest for warships. Okay, next largest for cargo ship, next largest for cruise ships. Okay, so the minimum omega, minimum GM and omega is designed in luxury cruise ships. So it can topple easily. Okay, so it has to go in what is a very calm waters. Okay, whereas your cargo ships are between warships and this one. Okay, so we'll stop here, students. Any doubt you can ask me. Today I went very slow, I do agree, but I think I have made my points clear. You've understood it nicely, is it not? Tomorrow we will go with problems. All the problems on fluid statics we will solve. Okay, student, this completes fluid statics. There's nothing remaining now. Okay. Next we will go. Next, we had started from May 5th, is it not? Today, May 25th, 20 days. We have taken. That's some of the classes we have missed, is it not? So 3, 4 classes we have missed. So we can say around 15 days, right? Around 22 hours are taken for this. Done, students. Thank you very much.